So we've discussed how to make predictions in games where both players have dominant strategies, as we saw in the Prisoner's Dilemma. Now we want to think about how to predict the outcome in games where one or even both players do not have a dominant strategy. And the way we're going to do this is to use a concept called Nash Equilibrium. This concept is named after John Nash, who invented it. And it's a concept that John Nash won the Nobel Prize in Economics for in 1994. In fact, John Nash actually did this work in his first year of graduate school at Princeton back in the early 1950s. It just took a while for the Nobel Prize to arrive. You may not have heard of the concept of Nash Equilibrium, but there's a good chance you've heard of John Nash because he was the subject of a movie starring Russell Crowe called A Beautiful Mind. We're going to think about Nash's idea and figure out how to analyze games using it. So let's begin with a game where at least one player doesn't have a dominant strategy. In this game, we'll see that player one, in fact, does have a dominant strategy because A1 is the best response to anything player one thinks player two might do. And remember, that's the idea of a dominant strategy. Strategy is dominant if it's always a best response. So this guy does have a dominant strategy, but player two does not. For player two, what he should do depends on what he thinks player one's going to do. A2 is the best response to A1, but B2 is the best response to B1. He needs to know what player one's going to do before he can decide what he should do. So he doesn't have a dominant strategy. But if you think about this game for a moment, player two should in fact know what player one's going to do. Player one does have a dominant strategy. It's A1. So two should expect one to play A1, and two therefore should play his best response to A1, which is A2. That means in this game, even though one player doesn't have a dominant strategy, we can be pretty confident predicting play of A1 and A2. Notice that what's going on here is that A1 and A2 are mutual best responses. They're best responses to each other. What John Nash did was to generalize this idea just a little bit to games in which neither player has a dominant strategy. Nash's equilibrium concept is to simply say that two strategies are a Nash equilibrium pair of strategies if they're best responses to each other. That is, if they're simply mutual best responses. Of course, it's natural to ask, well, why would we use this concept of Nash equilibrium? And it's easiest to think about it by asking what would happen if players are not playing a Nash equilibrium. So consider a pair of strategies where at least one of those strategies is not a best response to the other. Well, the player who is doing something that's not a best response is making a mistake. He should change what he's going to do. That means that this pair of strategies we're looking at is unstable in the sense that at least one player, and maybe even both players, have an incentive to do something different. That's always going to be true if you pick strategies that don't form a Nash equilibrium. Somebody, at least one player, maybe both, has an incentive to change and do something different. That's why we use the concept of Nash equilibrium to predict play. Now, in the game we just looked at, there was one and only one Nash equilibrium. That doesn't have to be the case. Some games have multiple Nash equilibria. An interesting example of a game like that is called the hawk-dove game. It's called that because each player has the possibility of choosing to be aggressive, that is, play like a hawk, or be passive, that is, play like a dove. If you analyze the hawk-dove game, depending on exactly how you set the payoffs up, you can easily see that this game might have two Nash equilibria, one in which player one plays like a hawk and two plays like a dove, and another one which is just the flip of that, one in which player one plays like a dove and two plays like a hawk. That is, one passive and one aggressive. What's not a Nash equilibrium is what might actually have been good for both players, that is, both to be passive, cooperate in some sense, and play like doves. That's not a Nash equilibrium, because if one player thinks the other is going to play like a dove, his best response is to play like a hawk and be aggressive and take more of the surplus here. So this game has two Nash equilibria, these two asymmetric things of playing like hawk and dove for the two players. This game has multiple Nash equilibria. That can easily happen. You can find one Nash equilibria, two Nash equilibria. What we need to look at next is what happens for games that don't have Nash equilibrium in these simple strategies. And we'll then pursue Nash's idea of generalizing the notion of a strategy to find that Nash equilibria really do always exist once we look at more complex strategies.